Okay, so for example number 8 class, so we are to determine the x and y components of our f sub 1 and f sub 2. Okay, and after getting the components, we are to express each force as a Cartesian vector. Okay, so we are required, so when we say x and y components of each force, so for f sub 1, okay, the x component is, let's say, f1x, and for the y component, f1y, while for the f sub 2, we have f2 sub x for the x component of f sub 2, and for the y component, we have f2 sub y. Okay, now our target is to express each force in the Cartesian vector. So therefore, what we are trying to solve here is the f sub 1, okay, in Cartesian form, which is f sub 1x, and you need to use the unit vector plus your f1y, and of course the unit vector j. While for the f sub 2, to express it in what do you call this, Cartesian vector notation, so we have f2x I plus f2yj. Okay, so this is really our target, but in order to express it right here, so we have to find these components first. And if you could recall, in order for us to get the x component of f sub 1, okay, so we focused here in this figure here. So f sub 1 is like this. Okay, this is f sub 1. So this, we have given here 30 degrees. Okay, 30 degrees. So obviously, class, from here, where is our x component? So since this is the x-axis, okay, so obviously our f1x is right here. This one, if you make a parallelogram there, so the f1x there is right here, f1x, or this is the same. Okay, so we will be making use of this angle here, which is 30 degrees. So what trigonometric identity should we use in this case? Okay, we have an angle here. Our unknown is f1x, and we are given here the hypotenuse. Take note, we have here a right triangle, class. Okay, we have here 30 degrees. This is our unknown f1x, and this is our given, which is the magnitude of f sub 1, which is 200. Okay, so the question again, what trigonometric identity should we use in order to solve for f1x? Is it the cosine, is it the sine, or the tangent? So obviously, since the side involved here is opposite of the angle and the hypotenuse, so opposite and hypotenuse is sine. Okay, so sine theta is opposite over your hypotenuse. Okay, plus it is not what we have discussed, the common way that when you try to solve for the x component, you will use the cosine. Okay, you only use the cosine theta if the angle that you'll be using is with respect to x. As you can see here, the angle given, which is the 30 degrees, is with respect to the y-axis. Okay, so if you want to use the cosine theta to get the x component, so you have to get the angle here. What do you think is the angle? So if the total here is 90 degrees, okay, so if this is 30, so obviously this is 60 degrees. So if you want to solve for f1x here, so you'll be using the cosine of 60. Can you follow? So cosine of 60 is the adjacent, which is the f1x, over your hypotenuse, which is f sub 1. That's why your formula will be f1x is f1 cosine 60. Okay? You can also use that. But like I said, in this case, I'll be using the given angle, which is the 30 degrees. And in that case, we will be using the sine. Like I've said, it's because the side here, which is the f1x, which is our unknown, is opposite of that angle. So substituting, class, sine 30 is equal to the opposite, which is this f1 x all over your hypotenuse, which is f sub 1. So therefore, the x component can be solved by f sub 1 sine 30 degrees. Okay, so substituting, class, your f sub 1 is 200 Newton sine 30 degrees. Okay, so your x component will be, so using your calculator, so we have 200 sine 30, and you'll have 100. And what will be the unit? The unit is Newton. So this is only, class, the x component. Okay, now what if you have used the cosine of the 60? Let us check if it will produce the same value. Okay, so f sub 1 is 200 Newton cosine 60. Okay, so 200 cosine 60. Okay, as you can see, class, it will give the same result. So class, any of this formula. Okay, again, you only use the cosine if the side of the triangle used is the adjacent. Okay, you also use this part sine if the angle or the part of the triangle that we'll be using will be the opposite, which is in this case opposite. Okay, given angle, this is the required, which is the opposite, and you have here the hypotenuse. For the cosine, okay, for the cosine, your unknown is here, the adjacent part, your given angle is here, and you have the hypotenuse. Okay, so that's only for the x component, class. Now how about for the y component? Okay, y component tayo. For the y component, let us take this triangle, class, this right triangle. Okay, so given the 30 degrees and the f sub 1, which is 200 Newton, okay, where do you think is the y component? So obviously the y component is this one, f1y. Okay, so using this angle, which is 30 degrees, what do you think? What trigonometric identity should we use? Since your f1y or your y component is adjacent of your angle, okay, adjacent means yung katabi niya, so we will be using the cosine. Can you follow? So cosine over theta is adjacent over your hypotenuse. So in this case, our angle is 30 degrees. Your adjacent side of the triangle is this f sub 1y all over your hypotenuse, which is f sub 1. So therefore, we'll be able to solve for f1y by multiplying f sub 1 cosine 30 degrees. Okay, so substituting 200 Newton cosine 30 degrees. So 200 cosine 30. You'll have 173.205, and the unit is still Newton. Can you follow? So we have 173.205 for our y component. Now let us check if you use this one, this part of the triangle, this one. So in this case, class, if you look here, okay, if you look at this triangle, if you use the 60 degrees, so the y component is right here. Okay, this is this part right here. So as you can see, f1y is opposite of your 60 degrees opposite. So therefore, in this case, you'll be using what? You'll be using the sine. Okay, so sine 60 opposite is f sub 1y over your hypotenuse, which is f sub 1. So you can solve for y component by simply getting the sine 60 of your f sub 1. So 200 sine 60, so that is 200 sine 60, you have 173. So see, the same answer that we will get. So again, any of this angle used to solve for the component, okay? But you can only use, of course, one. It could be you use the given, but make sure that you follow the positions. Of course, you need to analyze what side of a triangle should you use in order to use the appropriate trigonometric identity. Will it be the sine or the cosine or the tangent and so on? Okay, so that's for the components of f sub 1 and f sub 2. F sub 1 only, x component and y component. Okay, so to solve for the f sub 2, let us first make a copy of these values because later we will be using it. Okay, so for the f sub x component, we have 100 Newton. Okay, for f sub 1x, we have 100 Newton, and for the y component, we have 173.205 Newton. Okay, so we will be using that later. Okay, for now, we will be solving for the x and y component of our f sub 2. Okay, so if earlier we have analyzed this arrow here or this vector here, in this case, for the f sub 2, of course, we will be solving for the f sub 2. So we will focus in this figure here. Now, take note, class, that instead of the angle given, okay, as you can see, the given is the triangle or the side of, or the slope, rather, is the slope. As you can see here, the rise is -5, which is downward, and the run is 12, as you can see. So as you can see here, we have a right triangle formed. This is your f sub 2, this is your 5, and this is your 12. Okay, this is our f sub 2 there, and we have here a slope, so 5, 12, 13. So using our similar triangle, okay, so if this is your using this triangle, okay, so this is obviously your f sub 2 here. So what will be this part right here? Is it the y component or the x component? So obviously, since horizontal, so this will be our x component, and this vertical part right here will be our y component. Okay, so using the similar triangle, using these values, we will be able to solve for the value of our x and y component. So let's start with f2x. Okay, so in order to do that, you have to look for the same side. So if, for example, you are writing f2x here, okay, so what is his equivalent side on the other triangle? So since this is the f2x, so you should look here, which is 12. Okay, so you pick another side that is, of course, given in this case. So since we are given here the hypotenuse, which is f sub 2, so we will pick that f sub 2, which is the hypotenuse. So what is its equivalent value on the other triangle? It is 13. So you'll put here 13. Okay, so take note, this is the let's say this triangle of force, and this triangle is the slope. Can you follow? So whatever side you are looking here, so this is somewhat ratio and proportion, class. Okay, so this side f2x is proportionate to this side there, and this f sub 2 is proportionate to that side also. Okay, so since our target is this f2x, so f2x can be solved by simply cross multiplying. So f sub 2 times 12 over 13. Okay, so since f sub 2 is 260, So you'll have 260 Newton times 12 over 13. So what will be the value there? So 260 times 12 over 13. How much? 240. And the unit, of course, is Newton. Okay, and there you go. That's the value of the x component of f sub 2. Okay, now how about for the y component, class? For the y component, so the same, we will apply the ratio and proportion regarding the similar triangles. So since this is our target f2y, okay, the proportionate part is this, so equals 5. Okay, and given f sub 2 there, we will be using the 13. Can you follow, class? So f2y is f sub 2 times 5 over 13, or that is 260 Newton times your 5 over 13. So that is 260 times 5 over 13, 100. So we have 100 Newton. So take note, class, we have here the x and y components of our f sub 2. Okay, let us make a copy of that. So f2x is 240 and f2y is 100 Newton. Okay, so before class, we express our answer, our forces into Cartesian vector notation. Take note that our components here should be with a direction, and our direction, class, is used or can be expressed using signs. It could be positive or negative. Now remember that negative is when your direction is towards left or downward, while positive is when you are going up or to the right. Okay, now let us analyze or examine each of the components. For the x component of f1x, as you can see, the f sub 1, class, is going up but going to the right. Okay, going up and going to the left, rather. This is going to the left. So since to the left, his x component is going to the left, so obviously this f1x here is negative. Okay, but since his y component or its y component is going up, so obviously this is positive, so it will remain as like that. How about for the f sub 2? Now notice that f sub 2 is going down but to the left, to the right, rather, I'm sorry, it's to the right but it is going down. So since to the right, this will become positive while it is going down, so obviously this is negative. Can you follow? So you need to specifically state that signs there. It's very important. Now let us take this f sub 1 as our format of our Cartesian vector notation. Okay, so what we will do here, class, is we will simply substitute the values of our f1x and our f1y. And how to do that? So since f1x or the x component of f sub 1 is negative 100, so you'll simply write negative 100 and then you copy your I. Your I, class, represents your direction already. So negative I, okay, tells you that it is going to the left of the x-axis because I, class, is the unit direction of your x-axis. There. Now how about for the f1y? f1y is positive, so plus 173.205 and just copy your joule. So since, class, both of the forces are in Newton, so you will just put here Newton outside, or you could write here parentheses to indicate that all of these are in Newtons. Okay, as you can see, this is already the expression of our force, which is f sub 1 in Cartesian vector notation. So this is our answer, one of the answer actually, because we still have our f sub 2, which is expressed here on the same, but of course we will be using different value of the components, that of the f sub 2. So for the f sub 2x, this is positive 240, just copy the I, And for the F2y, that is negative 100, just copy the J. And don't forget the unit Newton. Okay? So there you go, class. Our answer. Again, this answer is the force F sub 1 and F sub 2 in the Cartesian vector notation.